Hi students, in last class we discussed about the introduction to bipolar junction transistors and different types of bipolar junction transistors when it is in unbiased mode and when we are applying the biasing, the possible ways of operating modes of BJTs we discussed in the last class. Today, operation of NPN transistor. If we know the NPN transistor, then we can easily learn PNP transistor. So you can observe the NPN transistor with biasing. So here we are always considering the forward biasing because the main application of BJT is amplifier. To make BJT as amplifier, we need to apply the emitter junction as forward bias and collector junction as reverse bias. So based on that, we are applying the biasing. So you can observe the diagram here. So in this, we are considering the NPN transistor. Emitter is made up of n-type material and base is made up of p-type material and collector is made up of n-type material. Here we are using the RE and RC. These two resistors, series resistors, are used to protect the BJT from heavy current. To make the emitter junction in forward bias, so it is nothing but forward bias is nothing but applying the anode terminal of diode to the positive terminal of battery and cathode terminal of diode to the negative terminal of the battery. Otherwise, you can say p-type metal is connected to the positive terminal of the battery and n-type metal is connected to the negative terminal of the battery. Otherwise, you can say the forward bias is nothing but it is always opposite to the barrier potential of the junction. Yes, simply we can consider it is n-type material. Now it is connected to the negative terminal of battery by using the RE resistor. It is acting as a limiting resistor, current limiting resistor, and the base p-type metal is connected to the positive terminal of the battery here. Yes, so we can say that emitter junction is in forward bias. Now coming to the collector junction, so collector is made up of n-type material. So to make this junction in reverse bias, we need to apply the positive potential. So collector n-type metal is connected to the positive of the battery and this base is connected to the neutral of the battery. Clear? So the emitter junction is forward biased by DC source VEE source. Thus the depletion region at this junction is reduced. So when the junction is in forward bias, the depletion region across the junction is reduced. We know. Yes. So the collector junction JC is reverse biased by applying the DC source VCC. So when the junction is in reverse bias, it increases the depletion region at collector junction. Yes. So the forward bias emitter junction, the emitter junction is in forward bias. Due to this, what are the majority carriers in the electrons move into the base region? Yes. So electrons are emitting from the emitter region to base region. This crossing of electrons at emitter junction is called emitter current. So whatever the charge carriers crossing at the emitter junction, that current is called emitter current. So as this flow of electrons through base region, here the electrons will recombine with the holes in the base region, p-type base region, Due to the light doping of base region and narrow width of base region, a few electrons will recombine with the holes. The remaining electrons will cross the collector junction because the collector is connected to the forward bias. The electrons will attract towards the positive terminal of the battery. Yes. So what are the current produced in the base region is base current, it is IB. Yes. And they are moving through the collector region to positive terminal of the external battery DC source. This current is called collector current IC. Yes. So here you can observe when emitter junction is forward bias. So majority charge gas in the emitter junction are electrons that are crossing the emitter junction and which are entering into the base region. So in base region we are having the holes or majority carriers, and the width of the base region is very small. Yes. So width of the base region is very small, and here the electrons will recombine with the holes in the base region. The remaining electrons will entering into the collector region. The entered electrons are attracts toward to the positive terminal of the battery. Here the width of the base region is very small compared to the diffusion length of electrons, because diffusion length of the electron is small. Then what happens? More number of electrons will recombine in the base only. Yes. So to reduce the recombination rate in the base region, so the width of the base region is always less than diffusion length of electrons in the NPN transistor. So that's why we are considering that base is narrow width and lightly doped one. Due to that, the majority of the electrons emitted by the emitter will reach the collector through the base region. Yes. So the charge carriers crossing at the emitter junction, the current produced that charge carriers is called emitter current. What are the charge carriers moving in the base region? That current is called base current. What are the charge carriers crossing at the collector junction and reaching the positive of the battery is called collector current. It is IC current. Clear? So here we need to observe, we are considering only majority charge gas. I said NPN transistor is a bipolar junction transistor. Where is other charge carriers? That means where is minority charge carriers? So we are considering only majority. What about minority? Yes. So here I am considering emitter emits the majority charge carriers when it is in forward bias. So electrons are crossing the emitter junction. Yes. So minority charge carriers are attached towards the negative terminal of the battery from emitter, that are holes. Clear? Now at collector junction, majority charge carriers are attracts towards the positive terminal of the battery, that are electrons are attached towards the positive terminal of the battery. The minority carriers of collector is holes that are repelled from the positive terminal of the battery, that are crossing the collector junction and that are entering into the base region. So the minority current is also produced when the collector junction is in reverse bias. So that minority carriers are crossing the collector junction. That current is called leakage current. It is very small amount of current. When the diode is in reverse bias, we will get the magnetic charge carrier current. It is very small. Yes. So ultimately here you can observe the majority charge carrier current, that means electron current, and the magnetic charge carriers in the collector or hole current. So here the total current is due to the electrons as well as holes in the BJT. So that's why it is bipolar junction transistor. So the most of the electrons from the emitter flow in the collector circuit and very few recombine with holes in the base region. So the collector current is more greater than the base current. Yes. So what are the current at emitter junction? IE is can be written as sum of base current and collector current. Since it is a bipolar device, we said the collector current consisting of two polarities, that are majority and minority carriers. Yes. So at collector junction, current the collector junction, majority carriers crossing and minority carriers crossing the junction. So the collector current consisting of two polarities, electrons as well as hole current. So it is bipolar. So the minority current component is called leakage current. It is, we know, it is very small current. Sometimes we are neglecting that one. So where it is represented as ICO. This ICO is nothing but current with emitter terminal is open. So we can write the total current at collector can be written as IC equals to IC due to the majority carriers plus IC due to minority carriers. It is represented as ICO. So otherwise you can write IC equals to IC injection plus ICO. So injector carriers plus minority carrier current. So your IC injection is nothing but it is an injection collector current due to the majority carriers crossing the collector base junction. Yes. So the collector current is sum of majority carrier current plus minority carrier current. Clear? Discuss about the operation of PNP transistor. You can observe here. So emitter is p-type material and base is n-type material and collector is p-type material. So we know emitter is heavily doped 1, collector is moderately doped 1, base is lightly doped 1. The size of the collector is more and the size of the base is very small. So here again we are considering in active mode. So to make that we need to apply the emitter junction forward bias and collector junction in reverse bias. So the PNP transistor has its bias voltages VEE and VCC reversed from those in the NPN transistor. Whatever we applied in the NPN transistor, it is reverse of that in the PNP transistor. Yes. So now P-type material emitter is connected to the positive of the battery, so it is forward bias, and in collector junction P-type material we are applying the negative terminal of the battery, so it is reverse bias. Now due to the forward bias of emitter junction, what happens? The majority charge carriers in the emitter junction emitter region P-type material holds to cross the emitter junction, that will some of the holes will recombine with the few of electrons in the n-type base region, then the remaining holes will reach the collector region and the collector holes are attracts towards the neutral of the battery. Yes. So the charge carriers crossing at the emitter junction, due to the charge carriers current is called emitter current, we know, and the current the charge gas traveling in the base region, that current is called base current. It is very small, and the current in the collector region is called collector current. It is IC current. So you can compare with NPN transistor. It is similar to NPN transistor, but instead of electrons you need to consider the holes, and the biasing is also opposite to the NPN transistor. That means battery connections. Clear? So next we'll discuss voltages. So now I'm using NPN transistor. Here in this NPN transistor, the three terminal voltage and its polarities for NPN is shown in figure. So this is the symbol of NPN transistor. You need to consider here. Yes. So this is the symbol, circuit element symbol. Yes. So here emitter is connected to the ground, and which is common to the both input and output. Yes. So the voltage applied to the base is positive and emitter is negative. So it is NPN. In this you can observe the direction of the current current on emitter indicated by the outside, so it represents the n-type material, NPN transistor. Clear? So in this circuit symbol, element symbol, so base, emitter and collector. So on the emitter terminal the arrow is indicated outside, so the transistor indicated as NPN transistor. If the direction of the current is inside the transistor, that is PNP transistor. So now we consider the NPN transistor. So the voltage between the base and emitter is denoted as VBE. Why? Because here base is applied with the positive potential and emitter is applied with the negative potential. So the base potential is more positive with respect to emitter. So VBE is related with positive to negative. Yes. So the base is positive than emitter because NPN transistor. The base itself made up of p-type material, and we are applying the positive potential to that one. Yes. So the base is more positive with respect to the emitter. And coming to the collector, here the potential between the collector to emitter is VCE. Here collector is n-type material, but we are applying the positive potential to the collector. Why? Because it is reverse bias. So the collector is more positive with respect to the base and emitter. So that's why this VCB, the potential between the collector and base is also positive. Clear? So you can observe here VCB, VBE and VCE. VB is the potential between the base and emitter. So base is more positive compared to the emitter. And coming to here, the collector is connected to the positive of the battery. So collector is more positive compared to the emitter and base region. So VCE and VCB is represented here. Clear? To make CB junction, that means collector to base junction, reverse biased, the supply voltage VCC is always much larger than the supply voltage of VBB. Yes. So to make the collector junction in reverse bias, we must apply the more VCC compared to the base voltage VBB. Clear? These are the voltages of a transistor. Yes. So for NPN transistor will be in active mode if emitter potential is less than base potential is less than collector potential. That means the collector potential is more positive, then after base potential is more positive, then after emitter potential. Clear? If it is PNP, then what happens? Emitter is high, then base is high, then after VC. So for NPN we can say VE less than VB less than VC. For PNP we can say VE greater than VB greater than VC. Clear? You can observe the PNP transistors here. So here you can identify the emitter terminal arrow mark is inside, that means the current is entering into the transistor. Yes, so it represents the PNP transistor. So here the voltage between the base and emitter is written as VBE. So here base is negative and we are applying the negative, so it is more negative as with respect to the emitter, and collector is also more negative than base because we are applying the negative to the collector. Yes, so these are the potentials of NPN and PNP transistors. In different conditions such as active saturation cutoff, there are different junction voltages of NPN transistor at room temperature, or it is 25 degrees Celsius. So for silicon, when it is in saturation, the VC potential is zero point 0.2 volts. When VC sat is 0.2, then it is silicon transistor is saturation. VB sat is 0.8, VB active or 0.7, VB cut-in is 0.5 volts. Similarly, germanium VC sat is 0.1 volts, VB sat is 0.3 volts, VB active is zero point 0.2, VB cut-in is 0.1 volt. These are the standard values of NPN transistor per room temperature. For PNP, same values but opposite signs. Clear? Then next we'll discuss about the transistor currents. So here we know the currents in the transistor are IE emitter current, IB base current, and collector current IC. Yes. So in NPN transistor, the IE current is that IE terminal having the arrow as outside out of the transistor. So it represents the NPN transistor. So IA current is going out. We know the sum of the base and collector current is nothing but IE. So IB and IC both are entering into the NPN transistor. IA is going out. Coming to the PNP, here emitter current is entering. So sum of base and current is base and collector is emitter current. So IE is entering, base and collector currenting are leaving. So it is nothing but case here only. So you can observe the directions of conventional current in the both NPN PNP transistors. Clear? So IG equals to IB plus IC. These are the conventional current directions. Thank you.